Okay, here we are, 6-5, day 2, where yesterday you finally learned how to do the derivative when there's a variable up in the exponent. So not really much new today other than practicing that. So I'm just going to start with one, like we had yesterday, and try to train your brain to tell yourself what you should be doing. So if I have the equation y equals sine x raised to the cosecant x. Well, what you should be noticing right off the bat, the red flag is right here. There's an x up in the exponent. Not the fact that there's trig functions, but this x that's up in the exponent. Up until yesterday, you did not have a way to do derivative there, but now we do. We hit both sides with a log, knock it down, and then do derivative after that. So again, I'm going to take the baby step and just write the natural log on both sides and not change anything. Some of you, I'm sure, are itching to knock this cosecant x down as a multiplier right off the bat. Go ahead and do it. We'll do it the next line. So now I use that log property that brings this down as a multiplier. So still have not done derivative yet. All I'm doing is getting this ready. Cosecant x times natural log of sine x. Now I'm ready for derivative. And you have a rule to do the derivative of natural log. It's 1 over u prime. So it's 1 over, and we're doing it implicitly because I don't have a y equals. I've got the natural log of y equals. So anytime it's not just a y equals, you jump into derivative, it's the implicit differentiation. And that just means when you get to the y term, you multiply by a y prime. So it's 1 over y times y prime. Over here now, you have, hopefully you're picking up on the fact that you've got an x term multiplied by another x term. This is a product rule. Those of you that don't pick up on it, just run right through, do the derivative of this times the derivative of this, and lose like 5 points. So don't be doing that. Okay, product rule says take the derivative of your first term. Derivative of cosecant, I'm looking it up because I don't remember, is negative cosecant cotangent. So that's the u prime times by the second term, the v term, plus, keep the first term the same, multiply by the derivative of the second term. The second term is a natural log. The derivative of a natural log is 1 over the u times the derivative of this. Derivative of sine is cosine. And then hopefully you're picking up, you'll have a cosine over a sine. These two terms here can turn into a cotangent and simplify. All right, so now I'm ready to finish it up. I want y prime equals, so I have to multiply both sides by y. So, and the y is sine raised to the cosecant. So I'm going to multiply by y here. Multiply by y here. So now I can finish it up and go negative cosecant x, cotangent x, natural log of sine x, plus this is cosecant. Cosine over sine turns into cotangent. All times by the y, which is sine raised to the cosecant. Done. So, anytime the variable's up in the exponent, you'll hit it with a log, knock it down, jump into derivative. Okay, this next one used to be a lot of work for you. Y equals 4x plus 9 raised to the 5th times 3x minus 7 raised to the 4th. This is a problem you had back in, I think, chapter 4 is where we did derivative. This is just a regular old product rule. But this is the one where it had all the baskets and the factoring and it got really long. Well, even though there's not x's in the exponent, you can still do this natural log derivative on both sides and see where it takes you. And you're going to see it's going to be a little bit shorter than what we did earlier in the year. So the directions will tell you to use natural log differentiation. That's a long word. To find the derivative here. So what that means is hit it with a log on both sides. So even though I don't have to, we're going to. just to see that it does come out a little bit shorter than what we had before. Okay, this side here I want to break apart before I jump into derivative. If I break it apart into two smaller logs, it's going to be a little bit easier on the derivative. So I'm not going to start derivative yet. I have the log of a product that breaks up into the sum of the two logs. So that's the log of 4x plus 9 to the 5th plus the log of 3x minus 7 to the 4th. Now at this point I can jump into log, but again I want to knock this 5 down out in front with my property and simplify first. I'll bring in the 5 here, put in the 4 here. Now I'm ready for derivative. I got 3 terms that I'm going to do derivative. And implicitly, because I don't have a y equals, so derivative of natural log of y is 1 over y prime. 5 carries along. Derivative of a natural log is 1 over the u times by the derivative of the u, which is a 4. Put that over 1. I'll put the 5 over 1 so I can keep numerators and denominators lined up. Plus 4. The derivative of the natural log is 1 over 3x minus 7 times by derivative here. And now our next line, we should be done. So we're going to multiply by y on both sides to eliminate this. That'll leave me with the y prime equals, multiplying here, I'll have 20 over 4x plus 9 plus 12 over 3x minus 7. And I've got that quantity times by the y, and the y was this original 4x plus 9 to the 5th, 3x minus 7 to the 4th. So that problem got a little bit shorter than what we were doing way back. That's really all I've got in here, is showing you can do natural log differentiation even when there's no x's up in the exponent. Actually, I want to do one more. I lied. Say y equals x cubed. And not that you would, I just want to show you the answer comes out the same. We're going to do the derivative, but using natural log differentiation. So that means hit it with a log on both sides. I like to bring the exponent down before I jump into derivative. You don't have to, it's just easier. Came out of nowhere. So I'm going to knock this 3 down. Now I'm ready for derivative. 1 over y times y prime equals 3 times the derivative here is 1 over x. We're going to multiply by y on both sides to get rid of this. Cancel, so y prime equals 3 over x times by the y. The y was x cubed. And if we simplify, I can cancel 1x, and I get 3x squared. Now let's take a look. If I had started with y equals x cubed, and done derivative with our power rule, this 3 comes down. X squared. There they are, they're the same thing. So you can start with natural log if you want to. A lot of times this is a lot more work than just our little rule. Here it created a shorter problem than we had in the past. Alright, so that's all I have. We've got page 269. Picking up problems 4, 8, 12, 16, 20, 24, 27 to 33 odd, 37 and 38 good story problems. Make sure you understand what the question is asking. Work hard on those too. Okay, that's it. After this, we're going to go into a quiz. So that'll be it for notes for today.